All right, so we can have reactions that happen instantly, and we can have reactions that happen over millions and millions of years. So what is it that affects the actual reaction rate, how fast a reaction can go? Well, there are 5 main things that are going to affect how fast a reaction is going to be able to go. There's the nature of the reactants, so sometimes it's just inherent within the whatever the reactants are and how fast or slow they go. Larger metals tend to react faster because they have a very low ionization energy, meaning that they can get rid of those electrons very easily. And they have a very high shielding effect. So the electrons, with the valence shell electrons, are able to react very quickly. Whereas if it's a smaller molecule, they're being held in much more tightly within the nucleus. So the nature of the reactants themselves actually play a major part in how fast or slow a reaction takes place. The second thing that that actually does affect reaction rates is concentration. So we know that from the collision theory, the particles actually need to collide in order for the reaction to occur. So the more particles you have, the higher concentration that you have, the more collisions that you're going to have with the reactants and products, and the reaction is going to go faster. So higher concentrated materials will react much faster than diluted materials, just because that there are more of them, more reactants than there are, and they're able to collide easier. All right. Then the third thing is surface area. So if you have more surface area in your reactants, they have actually more reactant sites exposed. So they're able to react quicker. So if you think about let's just use something dissolved that's actually much easier. Let's talk about a sugar cube versus granular sugar. If you were to dump those equally into some water, it's easier for the granular sugar to dissolve rather than the cubed sugar, just because there's more reaction sites within the granular sugar exposed than the cubed sugar. So the larger the surface area, the faster the reaction will actually take place. The fourth thing we're going to talk about is that affects reaction rates is temperature. So as we increase temperature, we're increasing kinetic energy. Those particles are actually moving faster, and they're colliding with each other more often and more frequently. So if we increase temperature, we're going to increase the reaction rate. And actually, this is approximation, but for every 10 Kelvin or 10 degrees Celsius that we increase the heat, actually the rate of reaction will then double. So that's how much the temperature affects the rate of reaction. And the last thing that actually affects reaction rates, or how quick a reaction takes place, are catalysts. So you might know them from biology as enzymes. They actually increase the reaction rate without being consumed. They actually just change the reaction pathway and what in chemistry we're going to call the reaction mechanism, which we'll get in at another video. The opposite thing that slows it down are called inhibitors. They're things that actually slow reactions down, which are actually desirable as well if you don't want a reaction to occur. Sometimes inhibitors will actually cease reaction completely. So these are the 5 main things that affect how fast or slow a reaction will take place.